Okay, here we are with Space Tow Truck. I'm very excited. So let me read you out a little message that we got from Mr. Eric Laflamme, who, by the way, is a physics teacher. He said, "Hi, I'm the game dev of Space Tow Truck, and I saw you play my game on YouTube. It was really interesting to see you play, and I agree that the first levels of my game are pretty easy. As a physics teacher, I created this recreational educational game because I believe we lack games to feel, understand, and democratize pre-university physics. So I didn't want to lose players in the first levels, even for somebody who never did physics in their life. The downside is that brilliant players would get bored, but there's a puzzle mode to avoid that, basically. So, he says, maybe you want to try something more challenging. Chapters 1 and 2 are very easy, but it gets much, much harder in 5, 6, and 7. Acceleration, gravity, and the black hole and circular motion. Here's a Steam key. So we have a review code. I'm going to be reviewing this game, which means I'm going to be doing chapters 1 and 2 anyway, Mr. Eric Laflamme. But thank you very much for the code, and thank you very much for the message. It's really nice when developers do reach out and see us play their games, and we get that back and forth with them and understand the game a little more. So the demo was the demo, apparently, and it was easy on purpose. So we're gonna power through that, but we are still gonna do those early levels. However, I am going to it says start a new game. I'm gonna start a new game, but I'm going to do puzzle mode. And here's the thing. It says, in this mode, all levels are accessible from the start. The narration is greatly reduced and is limited essentially to giving information about the mechanics of the game. Here, there's this weird story, but it was just about being on the moon. It was kind of silly, and we saw what it was like. We kind of just wanted to get to the puzzles. I'm going to do puzzle mode, all right? Now, I don't usually do this in a game. But this game is heavily puzzle-based. The story is more of a joke than anything at best, as far as we saw from it. So I'm going to jump into puzzle mode, but we are still going to be going, through them in order, through all the puzzles in order. So I hope that's reasonable. I hope you find that to be okay. But the story mode was kind of a little bit of humor. There's a little bit of, there's the space tow truck system that's on the moon, and you're a robot that crashes the car on the moon, and stuff happens. But it was kind of slow and silly, and I was just like, give me the next puzzle. Here we go. So we're crashing. So we will have done some of these first levels, but because I wanted to kind of do this as, when I play a review game, I want to play it from start to finish anyway. So I'll be putting this up episodically. However, oh yeah, we do. This is the beginning. Yeah, you crash and then you call the space tow truck shop or whatever. Yeah, we'll be doing everything. Hopefully this first hour video, let's say, will encompass everything we did in the demo, and then we can get moving on chapter 3 as soon as possible. Ouch. Alright, it's not that bad. I'm okay. Oh no, but my car isn't. I need some help. Space Tow Truck Customer Service. Hi there. Thank you for contacting Space Tow Truck, the best space towing service this side of the moon. How can I help you today? I just crashed into the moon, as you do. My car looks completely totaled. Your car is never totaled with Space Tow Truck, the best space towing service. I am deploying help to your location. We appreciate your patience. Thank you. I wonder if that's a real number. We gotta call it. We gotta find out. But we don't want to be charged however much it is to call abroad. I'm not sure where Mr. Eric Laflamme is from, where he's based. But isn't that cool? Imagine having a physics teacher. I would have loved a physics teacher that could make games. Back to the Past achievement unlocked. What happened? My car's still totaled. How am I supposed to move around with this broken car? Space Tow Truck has developed a new, powerful new patented technology. We can help you using our innovative space satellite. What about power I can't launch without my car batteries? We see that you have lost over 500 batteries over the surface of the moon. It's a lot of levels, I'm pretty sure, because some levels we get 1, there's 2, there's 3, but even then, that's still a lot of levels. Over the surface of the moon, you will need to collect a few hundred to be able to take off. I have to retrieve them myself? I'll be there to help you every step and leap of the way. Let me teleport you to the nearest crater where a battery fell. Please hold. What? Let's go. I wonder if that noise picked up. Let's go. Let's go. I'm so excited. I'm super happy that that Mr. LaFlamme reached out. In the UK, we call all of our teachers sir. Okay, Moonstone, we've had a problem here. Okay. Welcome to the Sea of Moisture. To know more about its name, you can click on its name. I'm clicking on its name. Oh, this name. Here is the Sea of Moisture. The expanse is approximately 420 kilometers wide and 3 kilometers deep at its center. Galileo, among others, thought that the dark regions of the moon were seas, since he mistakenly believed that they were filled with water. Ready for a swim? The Sea of Moisture was produced by the impact of an asteroid a long time ago. Then the sea was flooded with lava during an intense volcanic period on the moon's surface more than 3 billion years ago. It's now covered with basalt, that is to say volcanic rock. Basalt is what gives the moon seas their dark color. Their dark color, a little bit incorrect spelling, but there are over 1,600 craters on the moon, which have been named after scientists and explorers. Of this, only 32 are dedicated to women. Wait a minute, I think I could introduce you to the history of mechanics and its evolution using the name of these craters. I could even introduce you to 32 women of the moon. Wouldn't that be great? Except that, to be able to tell you this evolution chronologically, I will have to move the names of these craters. You won't blame me, right? Okay, and that's gone. Maybe we'll find out. Maybe the levels are called the what is this? Introduction to the concept of position. Let's go. So, like I said, we've already done these ones before. We'll just kind of jump here. Achievement unlocks the transporter. That's all we've got. So what we need to do is move from here to here. We only get to move once. Recover the yellow battery by placing your vehicle at the same position as this one. So we need to move. When you've selected choice, we don't need to move on the x-axis, but we do need to move twice on the y-axis. So it's 10, 10, and we're going to be 5 on the x-axis still. Let's go. Okay, and this is what it's going to be like for just a little while. Just a little while. You're on a good star, the nearest star from the Earth, the Sun. And 2 achievements. It's very forgiving, very, Let's start the history of science. It's really, it's really giving us a lot of achievements. Very generous. You have just unlocked the name of the first crater, Thales of Miletus. If you want to know more about this scientist, don't hesitate to click on his name. I love this. I have to say, I love this. I might not be able to read all of it on these videos, but this is fantastic. I love that you're going to be able to find out all this information. Here's the Thales of Miletus. Thales is known to be the first true scientist. According to him, we must observe phenomena and look for natural causes instead of looking for mythological answers. Well, what do you know? The father of the scientific method, Occam's razor, just obviously look for natural causes instead of demons. He has 2 theorems in geometry, which bears his name, the theorems of Thales. Thales would have helped end a war by predicting a solar eclipse, although this claim is arguably a legend. He believed that water could explain everything in the universe. I really like that theory, because water is very bizarre in many, many ways, and I like that a lot. Predicting a solar eclipse, it's like Avatar. Of course, I would speak about Avatar. This scientist is teaching us about ancient scientists. Oh, what's this? Our teleportation tools. Okay, let's go. Another teleportation one. This time we have to do it twice. So first we want to go 520. Let's go 520, and then we want to go 2510. We'll go 2510. And that's going to be at 3 seconds. And we can change that as well, but you've got to wait the 6 seconds for each level anyway, so that's fine. What's this? Ooh. Technical note, our control panel linked to our innovative teleporter allows us to control the position of an object. God. We should read that afterwards. Oh my god. Here is Anaximander, a pupil of Thales of Miletus. He was the first Greek philosopher whose writings were kept in prose, that is to say, writings without poetry. He's the first to design a mechanical model of the universe in which the Earth, cylindrical in shape, floats motionless at the center of infinity. According to him, the sun is huge and very far from Earth. He believed that the infinite, the indefinite, and the indeterminate, called apeiron, was the basis of everything in the universe. So cool. It's really nice. Introduction to drones. So drones are little monsters that move in and out of our path, and so 2 seconds, it's going to be here, and then it's not going to move. So what we need to do is move here immediately, and then move away very quickly. So what we'll do is, we want to be... Oh, we're already at 0, and we want to be at 10. So there we go. And then, after 1 second, we want to be at minus 25 and 5. I think that looks about right. Let's look at this. What are all... Oh, my God. Oh, my God. Teleporter. Okay, position. Unit along the X, unit along the Y. Our control panel linked to our innovative teleporter allows us to control the position of an object. Eric LaFlamme, you, sir, are a total nerd. And it's awesome. This is very, very cool. Dual portal generators. Look at all this. Our control panel. Just, this is fantastic. Displacement, initial position, final position. Table giving the delta R if V is constant. Oh my God. This is just brilliant. The displacement norm, time interval, velocity norm, antimatter pulse generator. Oh my God. This is great. This is... Okay, well... The black hole generator showing uniform circular motion. What is this? Pure madness. We might actually need to refer to these charts at some point in the future. But for now, let's put you away and we'll just play the game. This is very cool. Oh, we've already done this one. Let's execute. So we need to get past these first 2 stages pretty quickly. 2 batteries. Heyo. Nice, let's move on. Heracletus of Ephesus. Here is Heracletus of Ephesus. According to him, movement and change are at the basis of everything that exists. His best known quote mentions that since the water in a river flows, you never bathe twice in the same river. Introduction to drones. Oh, we just did that one. What am I talking about? 1.4. Sure, that's the name of the level. No information this time. I think we've got to get here and then get away, right? Or do we only get to do it once? In which case we want to do this at 5 seconds. No, we can. So we'll go there immediately and then we'll come back. It always shows us once, the simulation. So we want to start at minus 10 plus, so minus 10. We always, X, then Y. On a graph, it's always X, then Y. You always go across, you know, over, like, through the corridor, up the stairs. That's how we would all, you know, down the hallway, up the stairs. That's how we would always remember it. X, Y. And then after, like, 1 second, we might as well just teleport straight back to 0, 0. Yes. Currently, what we're doing is we're putting... Oh, no. In fact, in that case, we don't want to do this at 0 seconds. Whoop. What we can do is... Let me look at this simulation again. How fast... Oh, yeah, it takes less than a second for it to get there. Wow, so actually what we want to do is at 5 seconds, we'll want to be minus 10 plus 10, and we'll start at 0. Oops, doing the wrong way around. So if we do this now, we're going to stay exactly where we are. We're going to teleport where we are, and when the drone moves past, at 5 seconds, we are going to teleport to the battery. Okay. And you can see that what we're doing is we're teleporting from 0, 0, from the center point of the axis every time. But soon you're gonna see that actually we have displacement from where we currently are. So we've got to figure out, okay, it's not just we need to get to 25, 10. It's where are we? Well, we're at 5:15, and we need to get to 25:10. So we only need to do the 15, and we minus. We're kind of calculating it from where we are instead. Everybody knows Pythagoras. He is the famous Pythagoras. Although he has not invented it, he is a well-known theorem which bears his name. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the 2 sides of the right angle. Remember it? Wink, wink. I'm going to assume that Eric LaFlamme is not English, is not his first language. There's a couple of errors here. Language errors. But I tell you what, anybody who can speak a second language better than I can speak my first is impressive. He would have been among the first to say that the Earth is round. Yes. He had, however, no proof of this assertion. According to him, the Earth just had to have a perfect volume. That is to say, the volume of a sphere. He discovered a relationship between the length of objects and the sounds they produce. Music and mathematics are linked by harmonics. Like a tuning fork. He would have said that the distance of the planets is related to harmonics. According to him, astronomy and music are linked. Isn't that wonderful? He saw the numbers as sacred and each number even having a meaning. Even had a meaning. Moreover, according to him, everything in nature could be described with whole numbers. 1.5. Here we go. End of area 1. And it looks like there are going to be 7 different areas. But we're going to be spending a lot longer on the later ones. A lot longer, no doubt. So, this one moves back and forth. Okay. So where are we safe? Where are we safe? What we want to do is, can I kind of scroll along here? This is great that I can scrub this. So we want to move here at like 3 seconds. At 0 seconds, we can move twice, you see. So at 3 seconds, because at 2 seconds it's going to be here. So at 3 seconds, we want to be at -15, 10. Then it's going to move there, and then at 5 seconds, let's say, just before it gets to us, at 5 seconds, we're going to want to move to 10, 20. Lovely, lovely. So we can let it do one cycle, and then as it moves, we'll teleport, and then when it comes back, we'll teleport through it again. Lovely. Very nice. The fifth nearest star from Earth, Wise. I don't think that's the full name. Wise J085510.83-0714442.5. Obviously. Obviously, that's the name. Let's move. Parmenides of Elia. Parmenides of Elia. According to him, we live in an immutable universe where nothing moves. The movement is only an illusion. I love the little emojis that he puts in there. You can tell he's a teacher. You can tell as a teacher trying to like grab the attention of students, adding little things, and it's very cute. Theory, which is the opposite of what Heracletus of Ephesus said. He would have been among the first to say the Earth is round. According to him, there were only 2 elements at the base of the universe, fire and earth. Oh my god. I have a confession to make to you. This crater does not exist on the moon, but this scientist was important for the development of the ideas of mechanical physics, so I could not help but to add it. Okay, we gotta start a GoFundMe. Can we name a new moon crater Parmenides of Elia? He tricked us. He got us with that one. Got us good. Alright, so Sea of Clouds. I think we've done a couple of these ones as well. Let's see. 2. Introduction, the concept of displacement. This is what I'm talking about. We should read about the Sea of Clouds as well. I'm having a really good time learning all this stuff. I might go, I might pause this and just go get some more water. We're going to be thinking. We need to be hydrated. Ready to make displacements. I'm very happy we don't have to... The story is a little... It's a little on the nose and it's a little silly. And it was even more reading. Honestly, if I'm going to be reading something, I think I prefer to be reading about these facts about the moon and the scientists than I would the kind of silly story of the game. So that's kind of what I've chosen to do. Displacement is a variation of your position. So basically that's from where we are, not from the starting point. And you can tell this because it's the yellow background and it has this, we have the delta here instead. Okay, displacement. Electric impulse generator. Linked to dual portals generator allowed to displace an object from an initial position. Displacement is a change of position between a final and an initial. Dun, dun, dun. All right, back. Here we go. This is a confusing one because I want to press that, but it's down here. So first we're going to go -10, 5, and then at 3 seconds, sure, that's totally fine. What we need to do is we need to move to +10 plus another 10 to get back to the initial position. So we actually need to move 20. And then from here, we actually need to move up 2. So we move up 10. Each point of the graph is 10 right now. So here we go. So then we +20 +10. Perfect. Perfect. All right, we're getting there. We're getting through the grind so we can start working on the good stuff. It's going to get real tricky. This game is going to break me, no doubt. 2.2. Now I remember, in fact, we need to read about the Sea of Clouds. Here's the Sea of Clouds. It was formed by the impact of an asteroid about 4 billion years ago and was inundated with lava about 500 million years later. 500 million years later. Don't worry, whatever. Yesterday, basically. It has a width of about 700 kilometers. The sea has a crevasse over 100 kilometers long called Rupes Rector. It was discovered in the 17th century by Christian Huygens, who called it the Sword of the Moon, because it's, I guess, one big is a long line, 100 kilometers long. It would be due to a landslide. In 2013, Spanish astronomers saw and recorded the impact of an asteroid in this sea. And Zeno of Elea. Here is Zeno of Elea, this disciple of Parmenides. He enunciates paradoxes which prove that movement is impossible, such as the paradox of Achilles and the turtle. Everybody's heard of that. In this paradox, the rabbit can never catch up with the turtle because for every half of the road traveled, there will always be half of a half to go before catching it. According to its arrow paradox, a flying arrow is in fact motionless since it is at each moment motionless. So if you stop an arrow and look at it by one frame at a time, it's motionless. It's only when you put them together does it create motion. He would have been the inventor of the dialectic, a method of reasoning which highlights contradictions to seek to find the truth. And this crater does not exist on the moon, but the scientist is important for the development of ideas in mechanical physics, so I couldn't help but add it. Once again, we have been fooled. Mr. Lamb got us again. But yeah, the idea behind the turtle is if you, I move 1 meter, I move 2 meters, and the turtle moves 1 meter, and then it moves, and every time I'm moving, and it's moving, I'm explaining this very wrong. It's a very simple idea that basically there's always an infinite amount of distance to move because you can half a number and a number and a number. You can keep halving it, right? And you always have to reach that before you can get to the end of where you're going. And what it discusses basically is that you never can actually reach something. It makes no sense to reach something because there's always more to travel. And it basically means it's towards infinity. It's towards infinity. Instead of it being an infinite distance, it tends towards infinity, and so we have the illusion of movement is the concept behind it. But I mean, of course, makes no sense in the real world. If you think of it like that, it's more like a paradox. But it's very interesting to think about stuff like that. Like if you think about things mathematically and break it down to its core, it kind of breaks the world as we know it. But then when something has to happen because we see movement every day, and otherwise I'd never reach that door if I move this half of this distance, then half again and half again and half again and half again and half again. I don't know. It's an interesting thing to think about. I watch a lot of educational YouTube. I just have it in the background pretty much all day. If you want to know stuff like that, you should check out Veritasium. There's I like the computer science ones. There's the mathematics ones. What are they called? There's the stand-up maths with Matt Parker. I have a couple of his books. In fact, I have Matt Parker's Humble Pie right here. Real funny magician. He actually did do some magic tricks on stage with maths and stuff, but he's a real funny mathematician. They have a stand-up show that I would love to go see. I would love to be able to go see Matt Parker and the stand-up maths team. But let me check for you quickly. There is it's Computerphile? Is it Computerphile? Is that what it's called? It is, yeah. And then there's Numberphile. I was trying to think, is it Mathematics File? No, Numberphile. Numberphile is a fantastic YouTube channel. Highly recommended. In fact, I'm going to link these below. I'm going to link them all below. Veritasium, also phenomenal physics, science, maths channel. Just interesting phenomena. Of course, there's always Vsauce as well. I just consume that content. I have it on repeat all the time. It's really fascinating stuff. Anyway, let's move on with this game. I'm losing my mind a little bit here. I really am enjoying this. I'm having a good time. So, this is a little bit trickier. So, we want to move down to the bottom first because this drone ends there. So, we need to be there straight away. So, let's move down here. And I think we have 2 jumps. And the reason we have 2 jumps is because you can only go max 20. So if we need to move 5, 10, 15, 20, 25, 30, we can't make it, to reach this battery. So we have to jump back here and then back here. So we want to start on this one, which is 15 minus 10. And then we're going to displace after 2 seconds is fine. Then we're going to displace. We need to go... this is 15, so we're going to go minus 15, and we're going to go plus 10 back here. And then from there, 4 seconds, is that safe? 4 seconds is, you know what, we'll make it 5 just in case when he's out of the way. And then we have to move up 20. Oops, up 20, and actually minus 5 on this one, because we're going across and then up. Let's go. I think I've completely ruined the turtle and the moving the half distance. I've completely destroyed it. Plato, you should go check it out. In fact, I'll link that specific video. I'll link a specific video about that phenomena below. It's more of, like I say, it's theoretical mathematics more than anything else. Here is Plato. According to him, the material world is only an illusion because our senses do not allow us to see the real world. He invented the matrix. Knowledge is acquired exclusively by thinking it, and it is not necessary to do experiments in order to validate theories. The real world is world of ideas. Well, we don't agree with that. Inspired by Empedocles, who believed that love and hate engendered the 4 elements that make up all things on Earth. He believed that the world is made up of 4 elements: earth, water, air, and fire. Very common idea in kind of mythology as well. Since there are only 5 solids with all sides, faces, and angles being equal, such as the tetrahedron, the cube, etc., 5 Platonic solids, he would have related these solids to the 4 elements that make up all material things. The Platonic solids. Oh, there you go, the Platonic solids. I should have an example of the Plutonic Solids somewhere, and if you, in case you want to know, get some D&D Dungeons and Dragons dice, because there's a D6 which is a cube, there's a D3 which is a tetrahedron. No. What have we got? We've got you've got your pyramid as a D4, you've got a D6 which is your cube, you've got your D8. Which is it's your double pyramid. I can't think what they're called. You've got your D20. What's that? An icosahedron. Was basically the 5 main dice of D&D. Are the Platonic solids. I did watch a video recently of somebody else talking about there are way more Platonic solids, but they're in all sorts of crazy dimensions and stuff. Super weird and single. Like 1D solids and all sorts of nonsense, like crazy mathematical stuff that broke my brain. According to him, the universe is alive. It would even have a soul and an intelligence. For him, the Earth at the center of the universe is spherical and fixed. The moon and the sun revolve around the Earth in perfect circular orbits. We know that is not true. The stars are on a sphere called a fixed sphere. Completely incorrect, sir. Very sad, very sad. Let's move on. I'm going to just do this world. I'm just going to do this world because I've ruined everything now. Now I really want to go. Now I really want to go and I want to go play with some I want to go watch some YouTube videos, and I'm going to just link a bunch of stuff in the it's going to be a bunch of nerd stuff below, but I find all of that fascinating. Like I just consume that constantly. I'm gonna put that below. I'm gonna put the. Let me make a note. What did we talk about? We talked about turtle movement. Okay. We talked about the Platonic solids. I'm just gonna make a note to everything I should link below. There's a Numberphile, and the stand-up maths, and. What else? We have so many good math channels. There's Veritasium, of course. There's Vsauce, of course. There's a couple of other ones as well. I'm gonna add a couple more. And if you're into that stuff, you are going to have hundreds of hours of excellent edutainment underneath this video. Highly recommended. Let's go. I'll shut up now. I'll get back to the game. Cat. So we only have 3 jumps. We have 3 jumps in initial position, which means we have to land, jump, jump, jump. Now, that car doesn't move for a while. So we can jump at 5, we can jump at 6, and we can jump at 7, or we can't. That's 6. So, what I think we need to do is go do the... Can we go... this is 5, 10, 15, 20, 25. We can't do that. We can't go from here to here. And if we go from here to here, we have to wait until 5 seconds before we go here. 5, 6, 7. So we can't do that. What we need to do is go somewhere and then back. We need to like go here. 5, 10, 15, 5, 10, 15, 20. So we're going to go bottom right, top left, top right, bottom left. Okay, so this one first. This one is a complete initial starting position. So we want 5 minus 15. Then at 2 seconds, that's totally fine. We are going to displace ourselves 5, 10, 15. So minus 15. And positive 5, 10, 15, 20. 5, 10, 15, 20. At 4 seconds, we are going to displace ourselves 5, 10, 15, 20 across. 5, 10, 15, 20. And 5 on the y-axis. Then we're going to displace ourselves again. Minus 5, 10, 15. And 5, 10, 15. Let's see how we do. Should go here, and then we're going over here, and then this drone should move out of our way, and we get right there. Sweet, okay. Excellent, good work. Good work. Solve it by working backwards, right? Solve it by working backwards. Where do we have to be at what time? And we can kind of like knock that one out. Here is Aristotle. Inspired by the theories of Empedocles and Plato, he adds a 5th element to the theory of the 4 elements, ether. According to him, this divine material exists beyond the orbit of the moon and allows to explain the universe. His theory has a certain logic that each element seeks purity and tends to return to its natural state. For example, the earth that holds in air wants to come back to the earth. The theory tried to explain gravity. In total disagreement with Plato, he believed that observation allows us to understand the world around us. According to him, an object twice as heavy falls twice as fast. We know that to be incorrect because of gravity is a constant. According to him, a moving object must be constantly propelled to continue its movement, whereas we know that an object in motion tends to stay in motion. For example, he assumed that a moving arrow was propelled by air coming from the front of the arrow and rushing towards the back of the arrow, which was supposed to propel it. That's kind of funny because that's kind of how flight works, right? Like on an airplane, like all you're doing is you're boosting forward, and with the wings you're causing difference of air pressure to get lift. And it's kind of the idea that the air is hitting from the front. Obviously, he needs to explain wings and stuff and the difference of air pressure, but it's kind of a funny idea that it's kind of almost there, but not quite. But obviously, air coming from the back is just going to be air resistance. From the front, he believed that the universe is made of 55 spheres with different rotational speeds. According to him, the center of this universe is Earth. We know that's not true because we are very unimportant in the universe. According to him, the Earth is a sphere, and unlike Pythagoras, he had stated the same thing without providing any proof. He gives experimental proof to this claim. For example, he mentions that the shadow of the Earth on the moon during lunar eclipses is always the shape of a circular arc. This is only possible if the Earth is a sphere. His beginning of scientific thought. Was it Aristotle who put down the 2 cylinders and measured the shadows and the different times of days to discover the size of the Earth? I can't think who that was. Anyway, introduction to timed grenades. Oh, this one. Yeah, so we've done this one as well. Basically, we need to not be in an area when they explode. But we can be there afterwards. So we have 2 initial positions. So what we're going to do is we are going to move here as initial position. Then we are going to move here as an initial position. Nope, here as initial position. And then we're going to displace down. So we need to move after 0 seconds. We're going to move here. Then after 1 second, we want to move again. So here, -5 plus 10. Then at 1 second, we want to be 5, 10, 15, 20, 25. Can we do that? We can. We can do 25 now. And then up 5, 10, 15, 5, 10, 15. And then at 2 seconds, or 3. Ooh, this is an issue. This is an issue. At 3 seconds, we have to displace. Can we, once that thing explodes, okay. Once that thing explodes, can we go near it? Because in that case, what I'm thinking is what we do here is we actually go to, this is an initial position. This is a position, so I actually did this incorrect anyway, because this should be a, this is a teleportation. So, minus 5, 10, that's where we immediately teleport, and then we want to immediately teleport to 25, yes, at 1 second, and then at 4 seconds after this grenade has exploded, we want to move up 5, 10, 15, 20. Let's try this out. So we move there, and then just before the grenade explodes, we get out of the way. And we move there. Oh, no. Oh, but the level ends, so we're still safe. Interesting. Okay. Good, good, good. We're getting there. I'm really enjoying this. I'm really glad we got to come back to this. Aristarchus of Samos. I'm very glad we don't have to do the story. I actually thought the story was the worst part of this. All of the science stuff is awesome. Here's Aristarchus of Samos. He's the first to have proposed that the sun be at the center of the universe, the heliocentric model. Unfortunately, his proposal fell into oblivion for almost 2,000 years. Though through observation and using geometry, he finds that the sun is 19 times farther from the Earth than the moon. In fact, it is 389 times farther. Using the size of the Earth's shadow on the moon during a lunar eclipse, he estimated that the sun is 7 times the size of the Earth. In reality, it's 109 times bigger. You tried. Oh, oops. Wrong level again. Damn. You tried. Did better than I would have done. Okay. This is a big level. This is really big. This is really big. So, we can still only move. So, we get one initial position. We get a displacement, and we get an initial position again. So, I'm thinking we teleport here. We display back here, and then we teleport down here. Right? No, because you can't do that. You've got to displace down here. So, we want to end at 2020. Because that's where we're going to be up here. Oh, oops. Minus 2020. Minus 2020. That's where we're going to end. But first, we need to go here and then to the battery. Because what you're seeing is this is minus 25, 25. We can't get there with any of these. So we need to get close and then displace it at 1 second. So we are going to go to 15, minus 20. So I'll teleport us here. And then we are going to displace a further 10 on the x-axis and another minus 5 on the y-axis. And then at the end of that, we'll teleport up to get this second battery wherever we want. There we go. Before that explodes, we come here and then we pop up over here. Sweet. Sweet. We're getting there. The 10th nearest star from the Earth, Ross 154. Okay. Ross 154. Euclid. Oh, there's also a really good game on mobile called, is it Euclidean? It's just about geometry. It's a super cool game. You've got to basically make shapes, only being able to use intersections and other lines. It's a lot of fun. It's kind of like teaches you the idea, the basics of Euclidean geometry. He published the book Elements, a compilation of the geometric knowledge of the time. His book Elements remained the core of mathematics for nearly 2,000 years. The geometry that is taught throughout the world in elementary, secondary, and pre-university schools is that of Euclid. Awesome. Yeah, really. There's so much I've got to link in the bottom here. It's going to be insane. Euclidean. I think it's called Euclidean. Game. Mobile. It is a mobile game. But it is awesome. It's one of my favorites. One of my favorite mobile games. Let's go. Next level. I'm gonna have so many links down here. It's gonna be ridiculous. Right, so we have an initial position, a displacement, a position, and a displacement. So if I get this correct, I'm thinking we move, displace, move, displace. That's fine. So we're going to move here, which is minus 15 and minus 20. So we're going to be here. And then we displace to here, which is a further minus 15 on the x. and -5 on the Y. Then we only wait 1 second before we, because this is a 2-second timer, we wait 1 second before we go 20-20, so maximum. And we only wait 2 seconds before we displace a further 10 and 10. So 10 and 10. Let's try it. Here. Sweet, we're crushing these early levels. I'm liking what I'm seeing so far. This is, like I said, this is the very simple stuff. This is very simple stuff. We're going to get into the good stuff very soon. Hopefully. He said 5, 6, 7 are where it gets really crazy. But 3 and 4 should hopefully be interesting as well. What is this? This probe was sent by NASA on January the 7th, 1968. And made a successful landing on January the 10th, 1968, in a mountainous region just over 2 kilometers from its initial target. It was the 7th and final space probe in NASA's Surveyor program. This program aimed to study the characteristics of the lunar soil in order to prepare for the crewed missions to the moon, which were only a year and a half later. In its Surveyor program, this space probe was the 18th... was that what? What am I talking about? Was the 5th in the 7 to have made a successful landing. I was thinking, completely thinking about the landing on the moon. It took and transmitted to Earth more than 21,000 photos of the moon, Earth, stars, and the solar corona. The moon's soil was also analyzed in order to know its composition. I don't have any, like, moon stuff, but I have Curiosity. I have a little Curiosity rover on my desk. That was it's like a little Hot Wheels one. It was just limited edition Hot Wheels. Curiosity. That's a Mars rover. Long gone now. Long gone now. Archimedes. He was Archimedes, inventor and prolific experimenter. He was the first to understand the principle of leverage. He would have said, "Give me a lever and I will lift the world." Yeah, it's a very famous one. I remember that one. As he was taking his bath, he would have said, "Eureka! I found it," because he would then have understood why certain objects float on water. I don't think... Oh, is that... Okay. But that's a weird way of saying it. As far as I understand, he shouted out Eureka because he filled his bathtub with water, filled it, and then got into the water. And it was more about the displacement of the water. When he got in the bath, the water spilled over the sides, right? He thought that he was getting into the water, but of course he's taking up the same space as the water. And it went over the sides, and he understands... about why certain objects float on water, but also that kind of displacement, and it splashed everywhere. They say it splashed everywhere. He screamed Eureka, and he ran outside through the streets naked. This would have allowed him to prove that King Hieron's second crown was not made of pure gold. He would have calculated the value of pi with great precision for the time. To find the value of pi, you have to divide the circumference of the circle by its diameter. Archimedes' trick was to separate this circle into 96 pi tips. Then he would unroll them to measure the circumference more easily. Its result has been the most accurate for over 500 years. And a legend mentions that he would have suggested to the Greek army to use the parabolic bronze mirrors so that they concentrate the rays of sun on Roman boats. This trick would have burned the ships and sank them. I heard that one as well. I'm not sure if that's true, but that's a very interesting one as well. The calculating pi, there's also a great Veritasium video about calculating pi with pizza. That one's, I think that was from Pi Day this year or last year. But there's also a great thing about calculating pi on Numberphile, about using matchsticks and just kind of randomly distributing matchsticks and using them to calculate pi. Really cool trick. Damn, I watch too much edutainment content. Oh, we've done it. What am I talking about? We're done with this world. I need to shut up gushing about all of these awesome channels, but I'm going to link a crap ton of stuff below, and I would urge you to go check it out. It's all very, very cool. Let me know what you think. This game has... we kind of covered this in the demo already, so nothing too new. A little bit easy maybe right now, but we're getting there. We're getting through it. But I'm having a good time so far. I'm excited to see what World 3 and 4 bring before we get to the real hardcore stuff in 5, 6, 7. Thanks for watching. Thank you, Mr. Eric Laflamme, and I'll see you next time. Bye.